All right, absolute value equations and inequalities. Hey, that's going to pick y'all up back there if you're talking under me, okay? All right, absolute value. This is my middle school definition. It's the distance from a number, or it's the distance of a number from 0 on a number line. All right, so if I have this number line, and I have 0 right here, okay? If this is 5 and this is -5, if I'm counting, okay, right here, we know that this is 5 units away, but this one is also 5 units away. So what does that tell me about the direction of the number? The direction doesn't matter. As silly as this sounds, if I got in my car and I drove around backwards around the school, is it going to take miles off of my car? No, it's still going to add them up. So it doesn't matter how far you go, okay? It's still going to be a positive number. So checking how far a test score is from the class average, I could say you're 5 points above or 5 points below. All it's doing is telling me a direction, but it's still the same distance no matter whether it was above or below, okay? All right, measuring how much a car drifts from its lane while driving. Y'all better not do that. Calculating tolerances in construction, like the plank can be 2 inches longer or shorter than 48 inches. This is also called a margin of error, okay? So there are some allowances. When I get a 20-ounce bottle of Coke, okay? When I get that, does that mean that there's always exactly 20 ounces in my bottle? No. There's a little bit of a margin of error because sometimes the machine just cuts off a little too soon or doesn't cut off soon enough. It happens, right? Okay. So, since distance is always recorded as a positive number, the absolute value will always yield a non-negative number. Now, I say non-negative here because 0 is included, okay? 0 itself is neither positive or negative. So I can include 0 there. All right, so it follows then that the absolute value of a number can never be equal to a negative number. So we will never have just flat out absolute value bars with stuff inside of it set equal to a negative number, okay? Here's my absolute value bars. There's nothing on the outside of them, okay? And this right here, this is important. I'm going to put an exclamation point there. Because of what? What's that little thing in front? Yep. This is the problem. Okay? The negative is the problem. So we're going to see absolute value bars in equations and in inequalities, okay? Solving them means thinking about all the possibilities that could represent those distances. So how are we going to do this? All right, flip it over. Okay, the very first thing that we want to do is we want to isolate my absolute value expression, okay? It does not matter what's in those absolute value bars, okay? What matters is that there's nothing outside of them. So I'm good right here. Now, the stuff inside, okay, we'll later call this the argument of a trigonometric function, okay? So I'm going to just kind of refer to this as the argument or the stuff inside, okay? So right here, this 2x minus 5, I want it to total up to equal 7, because the absolute value of 7 is 7. What else could it equal? -7. So what we're going to do is we're going to take the stuff inside and we're going to break it apart into two separate equations. One with a positive and one with a negative. Okay, notice that the absolute value bars are gone now. So I can have it set equal to a negative. That was the problem earlier, right? The absolute value bars. Y'all okay? Yeah. I'm more awake than y'all. And I promise you, I got way less sleep than y'all did last night. I'm tired and I hurt. Okay? All right, here we go. Right here. I want to solve each equation separately. So right here, let's add 5. So that's going to give me 2x equals 12. So x equals 6. And then right here, I'm going to add 5. -7 plus 5 is -2. Okay? And then when I divide both sides by 2, I get -1. All right, so you can list your solutions like that, or as we have been working with set notation here lately, we could have it like this. It doesn't matter really what order the solutions you put in, okay? I probably should just get in the habit of putting everything least to greatest, but it doesn't really matter right there, okay? Now, I'm going to check this. If I go plug 6 back in, 2 times 6 is 12. 12 minus 5 is 7. And the absolute value of 7 is 7. Right here, if I plug in -1, 2 times -1 is -2. And -2 minus 5 more is -7. And the absolute value of -7 is 7. Okay? So, we have a typo down here. Okay? There are two cases that we need to remember. It will have no solution if the equation has the absolute value bars set equal to a negative. Remember, that's the problem. So here, I'm going to say that my B, well, I get what they're saying. So I'm just going to say the right side cannot equal a negative. They're saying B is greater than 0 here because if you plug in a negative number, or if you plug in a positive number for B, it becomes the negative of that number. Okay? So, right here, the absolute value of x plus 3, can that be equal to -4?
Yes.
Woohoo! The absolute value, can it be equal to a negative number? No. So I'm going to put a slash through that. And I'm going to state no solution. Y'all make sure you're on the lookout for that, okay? All right. And then there might be some where we get all real numbers. Okay, so let's look into that. Okay, we're going to hop, skip, and jump around. Okay? All right, here we go. The first one, actually what I'm going to do, I'm going to use my highlighter, and I'm going to go highlight my absolute value bars. If y'all have a highlighter or somebody around you has one, if y'all will pull that out and share it, please. I might actually do all of these and skip around on the next side. Hey, y'all need to make sure you're paying attention to me, okay? Y'all don't need your laptops right now. All right, here we go. Right here, the absolute value bars are already isolated, okay? So what I'm going to do, there's two numbers that I could plug in right here, and that gives me a positive 13. And that is simply x equals 13 and x equals -13. Done. Okay? Right here, the 3x plus 2 is on the inside, so there's nothing I need to do to isolate this, okay? Everything else around the outside of the absolute value bars is already taken care of. So I'm going to take the 3x plus 2, and I'm going to set it equal to positive 5. And I'm going to take that 3x plus 2 and also set it equal to a negative 5. And we solve the equation. So 3x is equal to 3. So what is x equal to here? Okay. All right, then I'm going to subtract 2. So that's going to give me negative 7. Is it okay for me to get fractions? Yes. Fractions are our friends, people. Fractions are our friend. Okay? All right, right here. I can set this equal to 0 because you can be 0 units away from 0 on the number line. You could be sitting right on it. So I'm just going to take this 2x minus 1, and I'm just going to set it equal to 0 and solve. Move the 1 over, and then divide by 2. So there you only have a single solution. Okay? All right. Right here, this is isolated. Okay? Right here, I'm going to take the x minus 4, and what am I going to set it equal to? 9. Okay? And? Perfect. So 9 and negative 9. I'm going to add 4 to both sides for both of them. So that gives me 13 and negative 5. Okay? All right. Then on this one, there is a plus 2 on the outside of my absolute value bar, so I need to move that. I want to isolate my absolute value. That means get the absolute value all by itself. So what's that going to be equal to? 6. And then you would go from there to solve it. Does that make sense? What would you set that 3x minus 5 equal to? 6 and negative 6. Okay? Let's move on over here. Okay? What will I set this equal to? Can't do it. Okay? You can't do it. Why? Because it's negative. So I'm going to put a slash here, and then I'm going to write no solution. Okay? All right. Right here, I want to isolate, so I'm going to divide by 3 to begin with. That gives me the absolute value of x minus 2 equals 5. Okay? So what do I do? Yep, but how? What do I set it equal to? 5 and negative 5, and you go from there. Okay? All right, can I do this one?
No. It's a negative. Yeah, you can.
Look on the outside of the absolute value bars, right? The outside has to be manipulated, okay? So right here I have the absolute value of x is equal to what?
Negative 5.
Whoa. Positive 2, because I just divided both sides by negative 2. Okay? Now look, can I do this now?
Yeah.
Yes. So here x equals 2 and x equals negative 2. Okay? Are you with me so far? All right. Let's take a look down here at this one. Okay? All right, what's the first thing that I need to do right here? Need to subtract that 1. So we have 2 times x plus, the absolute value of x plus 4 is going to equal 6. Okay? Then I have a fraction leading coefficient, so I'm going to multiply by the reciprocal. 5's cancel, 2's cancel. So here I have the absolute value of x plus 4 is equal to 6 times 5 is 30, and 30 divided by 2 is 15. So here you would set x plus 4 equal to 15 and good. All right, let's take a look at these. Okay, these look a little bit different, right? What's different about them? Yeah, you've got the absolute value bars on both sides, okay? Now, the good thing is, okay, for you and for me, is that they are isolated on both sides. Okay, there are 2 cases that happen here, okay? The first case is you drop the absolute value bars and you set 2x minus 5 equal to negative 3x plus 4. Okay? You write it exactly like it is without the absolute value bars. The second case is you're going to take what's on your first side, so that 2x minus 5, and you are going to set it equal to the opposite of what is inside those parentheses. Oh, yeah, the opposite of what's inside the absolute value, okay? So right here, you dropped the absolute value bars and you wrote it exactly like you had it, okay? The second case, the only thing you did, I did not change what was on the left side, okay? But what I did do was I took what was inside those parentheses, I grouped them together, and I put a negative out in front of the whole thing. Okay? So right here, I'm going to add 3x to both sides, and I'm going to add 5 to both sides. So this gives me a positive 5x is equal to 9. So on this side, I get a fraction, 9/5. Okay? Now right here, the very first thing you need to do is you need to distribute this negative to change those signs. A negative 3x becomes a positive 3x, and the positive 4 becomes a negative 4. So I'm going to move the x to the left and move the number to the right. So I'm going to show here I'm subtracting 3x. I'm adding 5. Okay? So this gives me negative x is equal to 1. Do I want negative x? No. What do I want? And how do I get rid of that negative? What you multiply or divide by a negative 1. Okay? So those are your 2 solutions.
So we can get either of them?
You need both of them. Because both of those numbers, if you plug them in, you can only do one at a time. So like if I plugged in 9/5 and I simplify that, then I would plug in 9/5 here and simplify that. Okay, and it might not give you a pretty number, but as long as both sides are equal, you're good. Here, if I plug in negative 1, okay, let's just check this one, because this one's a pretty one. What is 2 times negative 1? Negative 2. And negative 2 minus 5 more? Negative 7. Okay, so I get the absolute value of negative 7 on the right-hand side. Now, if I plug in negative 1 over here, okay, that's going to be positive 3. And positive 3 plus 4 is 7. Are those equal to each other? Yes. Because what is the absolute value of negative 7? Positive 7, and the absolute value of positive 7 is also positive 7. So it doesn't matter what the sign is inside. Okay? Let's do it again. Okay? All right, we got two cases right here. I'm going to split the middle. Case 1. What am I going to write?
4x plus
Okay? Equals x minus 2. You just write it like you see it without the absolute value bars, okay? Now, the second case, you do not change the left side. But what am I going to do to the right side? Put parentheses around it and make it the opposite. Make it negative. Great job. Same thing. Okay? All right. You solve those equations. I'm going to pull my paper back. When you get your answer, see if you and your neighbor got the same thing. If you didn't, it's okay. We're not judging. Hey, Xavier, did you come from someone with a pass?
I came from Mr. Woods' house.
Okay. All right, you got two numbers? See if yours looks like mine. Y'all tell me if I messed up. So y'all be like error analyzing my work.
How'd you get -9 when you...
How you get negative notes?
Okay? So right here, when I subtract, that should be
Positive.
-5. Okay, so this should be a -1. Y'all, when I tell you, thank you. I went to bed at 4:20 this morning. And I have an hour commute. So that tells you how much sleep I got, which is not much. Okay? I'm tired. My math ain't mathin' today. So y'all gonna have to help me out. All right, here we go. I want you to do this one. I want you to do this one from start to finish. Okay? Use your previous problems as a reference. And once again, check my work against yours. Okay?
You showed up on the board.
Yep.
So then.
All right. You should have set up 5x minus 1 and 2x plus 8. Okay, and then number 2, 5x minus 1 equals the opposite of 2x plus 8. Sorry, you can't see that negative right there, but it is up here. Okay, so let's see. Subtract 2x on both sides, that gives me 3x. And add 1 to both sides, that gives me 9. So x equals 3. Then when we distribute the negative, that becomes a negative 2x and a negative 8. Okay, so if I add 2x, that's going to give me 7x over here. And here, that's going to give me negative 7. So I got negative 1.
If they both negative, I got negative.
You talking about this? Because I'm only if I'm $8 in debt and I only add $1 to my checking account, that's not getting me out of debt just yet. So it's still negative. But when you add it to the other side, to move it, you got to do the opposite. Okay? All right. Inequalities. Okay? Inequalities. I'm just going to skip to this part right here, okay? Sometimes we have to find all the numbers that are within a certain distance or farther than a certain distance, okay? When we do this, we have absolute value inequalities, okay? I'm going to highlight less than, which means the numbers are within a certain distance. So right here, I'm just going to put an example, okay? And I'm going to shade in between. This is within. They are within the 2 points. So less than or equal to. Okay? Either one of those. Now, greater than or equal to means the numbers are more than a certain distance. Okay? So a greater than inequality is going to look like this, where it's shaded on the outsides. Okay? Now, just notice the difference. Absolute value equations are exact values, but inequalities could be a range of solutions. Okay? All right, so get that about the graphs. And then we're going to take a quick look at how we'll do the equations or the inequalities algebraically. Okay? There's still some of the same processes. Okay? So down here, there are 2 cases. If it's less than or equal to, what is inside the absolute value bars? Okay? Is going to be inside the boundaries. You know how we did the opposite? So we set it equal to that number and its opposite for the equations. We're going to put the stuff inside in between our 2 values. But if it's greater than, okay, we have to split this up. And this is a little bit tricky, so I'm going to put a star here. You need to make sure that you look back to this as a reference, okay? All right, I want you to look at what my signs do right here. If I have the absolute value of A is greater than B, notice, okay, I've still got the positive and negative B value, okay, or whatever was on the outside. But I take the argument and I say it's less than the negative one, or the opposite, okay, or it's greater than the upper limit, okay, or what you were given to start with, okay. All right, let me show you what I'm talking about. Let's look on the very back. Notice this is the back page of the packet. Okay. We need to pay attention to my sign, okay? Right here, that is less than. Less than is within. So I'm going to take this stuff, the x minus 4, and I'm going to put it within the upper and lower boundary. So I'm going to have a 6 and a negative 6. And I'm going to add this negative 4 to both sides of that. What's negative 6 plus 4? Negative 2 is less than x. X is now alone, which is less than 10. So I'm going to come plot a negative 2 and a 10 on the number line. They get open circles because it's less than. And my x values are between negative 2 and 10. Okay? All right. Now, this is the one that is a little bit tricky, okay? So, I'm going to take this stuff that's inside. The greater than means it's going to be more than. It's got to be the outsides. So, I'm going to write this exactly how I see it. And then I'm going to take what I have and I'm going to flip the sign around and change it to the opposite.
Would you change the other, the stuff that's inside or not?
No, you leave this stuff inside exactly the same. All you're doing is changing or flipping the sign and fixing your values, okay? All right, now right here, I'm going to solve. So right here, x is greater than or equal to, let's see, that's going to be negative 5. So x is going to be less than or equal to positive 5. Okay, and then right here, I'm going to subtract 7 from both sides. That gives me a negative 9 over here. And when I divide by a negative 1 again, that's going to change the sign and the symbol. So my two numbers here are 5 and 9. What kind of circle will I plot this time? Closed. All right, now x is less than or equal to negative 5, so it shades to the left. And it's greater than or equal to 9, so I shade to the right. Okay? This one is the tricky one. Okay? All right, now, take a look at this real quick. You have stuff on the outside of your absolute value bars. That's a problem. We got to isolate it. So I'm going to move the 5. I'm going to start with the 5. That's 4 times the absolute value of x is less than or equal to what? 16. Okay? And then I divide by 4, and that's going to give me the absolute value is less than or equal to 4. Well, less than is within, right? So all I have to do here is set up those boundaries. There's nothing to move. You got negative 4 and positive 4. Both of them get closed circles. And where do I shade? Between them. Okay. All right, I'm going to start by isolating right here. I'm going to subtract the 2. That gives me 21. And then the absolute value is going to be greater than or equal to 3. All right, so I'm going to write it like I see it. And then I'm going to write it flipping my sign and changing that to the opposite. That's almost like keep, change, flip, isn't it? Okay? All right, now, what kind of circles do -3 and +3 get? Closed. Both of them, okay? Now, this says x is less than or equal to -3. Done. And then this one says x is greater than or equal to 3. Does that make sense with the greater than, it being on the outsides? Okay? All right. Walk me through this one. What would I do first?
Right out of here. So subtract 5.
Subtract 5. So 13 take away 5 is 8. Then I've got the absolute value of x minus 3 is less than 4. Now, this is, I've got the absolute value isolated, right? So because it's less than, this is within. So I'm going to put my lower and upper boundary on that.
Did you divide?
I did. I divided by 2. And then I need to get rid of that -3. So I'm going to add 3 to both sides. That's going to give me -1 less than x less than 7. They both get open circles, and where are they shaded? Whoop. In the middle. Okay? I want you to do the last one. Oh, no, I don't. I want to do this one with you. Okay, here we go. I'm going to subtract 6 first. Then what am I going to do? Divide by -3. What happens when I divide by a negative? My sign flips, and then that's going to give me a -2 over here. Okay, so what I want you to see is I started out with a less than, but right here it changed to a greater than. So it changed the type of inequality that I'm working with, okay? Now, the first thing I do is I write it like I see it. And then I'm going to write it, flip the sign, and change the sign. So you wrote it like you had it, then you wrote it and you changed the sign. Okay? All right, here if I add 8 to both sides, it gives me 6. And here x is going to be less than 10. Wait a minute, what's wrong? That is, what did I do?
To negative positive. You added the 8 back. I'm letting down. Would you make the 8 positive too?
Okay, you flip it on the negative one.
Wait, what did it part? Wait, I thought the bottom was 9.
All right, look, right here. So you see how this has the negative? We're going to make that one, we're going to flip that sign there. We're going to make that the less than. I want it to be to the left of my negative number. Does that make sense? Okay, and then I want it to be bigger than my positive number. So that's my bad, I'm sorry. Everybody makes mistakes. Okay, all right, so that's still going to be, let's see, this is going to be x is less than or equal to 6. And here, x is going to be greater than or equal to 10. They're going to be closed circles, and they're shaded on the outsides. Okay? Look, I made a big boo-boo there, but did I let it get me frustrated? No. Just take a minute and see if you can figure out, if I had a greater than sign, it should be shaded on the outsides. If my signs weren't right, maybe I wrote it down wrong, okay? Not a problem, okay? All right, I want you guys to log on to my open math, and I want you to use what time you have left, please. Okay, never mind. I will change some due dates. Okay, we'll work on this tomorrow in class too.